Okay, in this video we're looking at the factor theorem. Now, the factor theorem is actually just a corollary of the remainder theorem. So with the remainder theorem, it was that when you do p of x over x take k, then if you look at p of k, you get whatever the remainder is. Basically, all it is that the remainder equals 0 in the factor theorem. So it's specifically for that case, and that would tell you that x take k is a factor because there was no remainder. So we'll do an example question. So x plus 2 is a factor of f of x, find the value of a. So essentially what this thing means is that f of minus 2 equals 0. So we'll plug in 0 for the left-hand side, and then we'll plug in minus 2 for the x value. Should look something like this. And then it's just a matter of chugging through the algebra to work that out. So we get minus 16, we're going to get, let's see, that will be a minus 20. Take 2a plus a. All right, and then if we solve this, we're going to get, let's add a to both sides just so we can have a on the left. But basically we're going to get a is minus 36. Whenever you do this, it's not a bad idea to actually state out what f of x is again. So therefore, f of x should be 2x cubed, take 5x squared, take 36x, take 36. Now, if we've done this right, if we look at the graph of this function, we should see that minus 2 is an x-intercept. So we'll do that. And if we look at shift G solve and then look at all the roots of this function, we do indeed see that minus 2 is an x-intercept. There's some other ones, minus 1.5 and 6, which we'll talk about in part B. Hence, fully factorized f of x. So to do this one formally, what we need to do is take our function, so 2x cubed, 5x squared, take 36x, take 36, and we need to be dividing it out by what we know is a factor already, x plus 2. Now, we've seen a few polynomial divisions now. I would encourage you to pause the video and try this one yourself before you see the answer, and if not, I will chug through it now. So x going into 2x cubed, so that goes in 2x squared times. So we're going to be timesing 2x squared by all that stuff. You'll get 2x cubed, that's good news, and you'll get 4x squared for this next bit. Minus 5 take 4 gives you minus 9, and then we'll pull down the minus 36x here. So how many times does x go into minus 9x squared? It goes in minus 9x times. So we'll put that there, and then we've got to do this thing here. And really it's the minus that's included there, minus 9x. And then minus 9 times 2 is minus 18. Minus 36, and that will turn into plus 18 when we subtract. So minus 36 plus 18, I reckon that's actually just going to give you minus 18. So we'll get something like that. Now, how many times does x go into minus 18x? It goes in minus 18 times. And then we get minus 18x here. And then minus 18 times 2 is minus 36. So we get a remainder of 0. We were expecting a remainder of 0 because we already knew that x plus 2 is a factor. So that makes us very, very happy. And now we've got f of x fully factorized. So f of x is x plus 2. 2x squared take 9x take 18. Now it's not fully factorized because we still have to break down this quadratic into two linear factors. I will mention that if this quadratic does break down, then you can factorize it further. Sometimes it won't. If, for example, you get messy things and need to use a quadratic formula, if that was the case, this would be fully factorized. Now, we did already see before that the x-intercepts were nice numbers, so we should be able to fully factorize this. And if you're not super into graphing, what's probably a quicker method for checking the factors is going into equation mode, polynomial, and we've got a degree 3. So it was 2 minus 5 minus 36 and minus 36. So if you solve that, I'm expecting one of the solutions to be minus 2, as we saw before, and then the other two x-intercepts will be these. Keep an eye out for wording as well, because sometimes they're asking about it in using any of those three words. So all three of those words mean the same thing. Anyway, let's have a go at factorizing this. So we do have to sum and product it. Your calculator can just help you cheat the answers here, but we'll try and do it using sum and product. So we've got a 2 out the front here, and unfortunately we can't divide the whole thing by 2, so we're stuck with making sure that we've got 2x and x. Those are the only sort of ways you can times whole numbers together to give 2. It's 2 and 1. So now we can start trying to put numbers together that might times to give minus 18. So let's try 6 and 3, something like that. If we do that, then one of them will have to be minus. So let's maybe make that one a minus and see how we go. So we've got 2x with minus 3, just like that. So we get minus 6x, and we've got x with 6. So that's 6x. If we add those together, that gives us 0, which is not minus 9x. So that is not what we want. Now I could go on doing sum and products and try and get the right answer here, but your calculator does actually sort of tell you what it is anyway. You'll notice this first x-intercept is positive 6. So I would expect one of the brackets here to look like x takes 6. So I might actually use that to sort of cheekily know what one of the answers is in the sum and product. And then the other number would have to be 3, so that they would times to get minus 18. Anyway, if we do that, then let's just double check that it is actually right. So you're going to get 3x there, and when you times across here, you're going to get minus 12x. Add those up, you're going to get minus 9x, which is what we wanted, because that was the number in the middle here. So there we are. All right, as with these sum and products, you can read off your brackets like this. So it's 2x plus 3, and it's x takes 6, just like that. Cool. And we'll just move that bracket back a little bit so it looks nicer. So that is our function, fully factorized. Therefore, all the roots are x equals minus 2 from that one there. Here, you're trying to solve 2x plus 3 equals 0. So x equals minus 3 over 2. And then here you're trying to solve x takes 6 equals 0, so x would be 6. And those are the same x-intercepts that the calculator said, so that is very good news.